Hey friends, Jim here with Science Talk. Want to share with you this quick little article that appeared on the online publication EOS. And as we can see here from the title, the world's roots are getting shallower. Root filled soils are hotspots of nutrient cycling and carbon storage. New research finds that the world has lost millions of cubic meters of rooted soil volume, and we're on track to lose much more. This is extremely troubling. So, this is a photo. Row crops typically have shorter roots than the native plants they replace, such as prairie grasses like the switchgrass shown here, which stretches 4.25 meters in length. Okay, this here, this brownish on the left side here, that's the root. This is what we would like walk through. As agriculture areas expand globally, millions of cubic meters of rooted soil critical for carbon and water storage, nutrient cycling, and soil formation are being lost. Plant roots act as engineers for Earth's surface, breaking up bedrock, transporting water and nutrients, stabilizing landscapes. They're so important that scientists have hypothesized that their evolution, beginning around 415 million years ago, altered landscapes in the course of Earth's history. Today, the world's roots are getting shallower on average, a new study finds. Shallow roots means there's less rooted soil, which could lead to decreased carbon storage, less efficient nutrient cycling, less fertile soils. Decreased carbon storage. So here we go again. We lose the soil, the carbon, boop, back to the atmosphere. Less efficient nutrient cycling. That impacts the entire ecosystem from producer to consumer. Less fertile soils. You have heard me discuss with you numerous times what? Crop yields are decreasing and the nutritional value, the nutritional quality is also decreasing. And we tie it in right here. Less soil, less efficient nutrient cycling. So there's your decreased nutrient quality. Less fertile soils will lead to decreased yield. Right here. Because if you have shallower roots, they can't hold the ground together as well as deeper roots can. And that increases erosional runoff. So Hauser et al., the paper that this little article is based on, provides the first estimate of global changes in the volume of rooted soil resulting from human-driven land use. They examined changes in many types of environments, but focused on the balance between two in particular: agricultural land, where row crop roots are shallower than those of native grasses, and forests, where woody plant roots typically reach deep into the soil. Agricultural land is expanding greatly as a direct result of human efforts. Reproductive efforts, because we just now officially crossed 8 billion people. Too many people on the planet. More and more people are going to require more and more land for housing and food. And in the practices we got going on here with the not as deep agricultural crops, the roots don't go as deep, we're actually then losing the soil, which ultimately will lead to crop failures and massive human starvation. As humans encroach, they tear down and ruin existing ecosystems, making them scarcer and scarcer. Meanwhile, forests expanding in some places, for example, high latitude boreal environments, as atmospheric carbon dioxide levels and associated warming increase. Okay, keep in mind though, the boreal forest, the soil is extremely acidic and it's really not suited for agricultural practices. But also, if you're talking about spruce trees, what have you, especially if you get in permafrost areas, the growth rate is really not great. It may take a century for a black spruce to grow a foot, 30 centimeters. So this is not the boon that they're making it out to be. The researchers use root depth data from two newly updated ecological databases, along with knowledge of past and present land cover types, to calculate average rooting depths for different ecosystems globally, past, present, and then projecting out into the future. They found that rooting depths, considered the depth above which 99% of an ecosystem's root biomass exists, are about 8 centimeters, or 5% the soil depth, shallower on average than they would be without human alteration. Okay, 8 centimeters may not sound like much, but it is. Okay? That's about 3-4 inches or something like that. Width of a hockey puck. But that loss, when you then sum that up, integrate it over the, all the land mass worldwide, that loss equates to roughly 11.6 million cubic meters of rooted soil. That's how much land you're losing. The study predicts, on the basis of intergovernmental panel on climate change projection of continuing land use change under a high emission scenario, that the volume of loss could be high as 43.5 million cubic meters of rooted soil by 2100. 43.5 million. With a global shallowing of about 30 centimeters. That's a foot. Okay. Shrublands in North Africa, the Middle East, Asia, Australia are likely to experience the most shallowing as they transition to herbaceous grasslands or agricultural and pastoral areas. The volume loss is especially striking to me, said Emma Hauser, who led the study. That represents a lot of below-ground space that is no longer performing the same kind of carbon and water storage processes as it was previously. There are myriad feasible consequences of shallower global rooting depths, including slower or less soil formation. Here we go. Decreased nutrient availability, and then further study is required. So what this is telling us is, if I can put it in such blunt, straight talk, we're losing farmland. You're losing the soil, you're losing farmland. You still think we can keep on adding more and more people to the planet? I don't think so. Remember, I did a video some time ago, might have been like 2 years now, where I discussed that the carrying capacity for humans on this planet is, looking at well over 40 papers in the peer-reviewed journals, 100 to 600 million people. That's what planet Earth can support, can sustain. In other words, people use, they extract the resources, but then allows the resources to be replenished. 100 to 600 million. We're at 8 billion. We're at 13 to 80 times above the recommended carrying capacity. Where are you going to house the people? You're going to need more and more land. Now, as we're seeing with this study here, to get more and more land to create food, the crops, the roots are not as deep, and then it's not stated here in the article, but the implication is that increased erosion takes place so that we lose all that soil. It's just lost. Lose the soil. This, of course, will lead to mass starvation. And as was alluded to, was stated at the end, and I've been saying this, crop yields are decreasing, nutritional values are also decreasing, and now we're seeing that you're not going to be able to store the water, not going to be able to store the carbon. Therefore, that's more carbon back into the atmosphere than being sequestered in the ground, and a decrease in nutrient cycle efficiency. So plants don't get the nutrients, which means you don't get the nutrients when you eat the plants. This is extremely troubling. And yet another example of how we're really mucking up the works. Not good news, but this is what's happening. Thank you for your time.